Today we're going to be covering Lesson 34-1, Constructing Models. We're going to be splitting this lesson into 3 sections, questions 1 to 3, questions 4 and 5, and question 6. Gina, Cheyenne, and Kim all use a photo app on their smartphones to share their photos online and to track how many people follow their photo stories. The people who choose to follow the girls' photo stories can also stop following or unsubscribe at any time. After the first 8 months, the data for each of the girls' monthly number of followers was compiled and is shown in the table below. And we have our table here. It looks like Gina's followers started at about 37. She went to 42, 46, 52, 56, 63, 66, 72. Cheyenne's followers, she had 2, 5, 9, 16, 33, 65, 128, 251. Kim's followers was 16, 29, 38, 42, 43, 39, 31, 20. Describe any patterns you observe in the table. As you share your ideas with your group, be sure to use mathematical terms and academic vocabulary. Precisely. Make notes to help you remember the meaning of new words and how they can be used to describe mathematical concepts. All right, what do we know about Gina's followers? It seems like they increase, right? The number of followers keeps going up. Question is, about how many followers does it increase each month? Well, if we look here, I'm going to write this up in pencil. Looks like we increase about 5 here. Here, there's about a 4-person increase. Here we have a 6-person increase. Here we have 4 people. Here it increases by about 7. Here it increases by 3. And here it increases by 6. So even though it's not the exact same number each time, it's around the same number each time. So it increases each month by 3 to 7 followers. Let's talk about Cheyenne's. Cheyenne's followers went from 2 to 5, 5 to 9, 9 to 16, 16 to 33, 33 to 65, 65 to 128, and then 128 to 251. So her number of followers increase, but nowhere close to the same amount each time. Here we go up by 3. This number goes up by 4. Now we've gone up by 7. Here we've increased by 17. We've increased by 32 here. $128 minus 65. We've gone up by 63. And 251 minus 128 is 123. It seems to me, not quite, but like here we had approximately 130, right? And here we have approximately about 260. It seems to me like these are almost doubling each month. So the number of followers is almost doubling each month. Let's talk about Kim's followers. Now, Kim was the only one that actually increased in followers. So she went up 13. Here she went up 9. Here she went up 4 and 1. But now what does Kim do? Kim now starts to go back down. So Kim's number of followers increases, hits a max, then starts to decrease. Use the terms linear, quadratic, or exponential to identify the types of functions that would best model each girl's total number of followers during the first 8 months. All right. Of these 3 girls, who would you think is the closest to being linear? I agree. Gina is our linear function. She's increasing by about the same amount each month. All right. Now my question is, exponential functions, remember those were the ones that were geometric, where we almost multiplied the same number each time. So whose function multiplied or was close to multiplying the same number each time? Cheyenne. We're doubling, so that's like a multiplication of 2 almost. So Cheyenne is exponential. And remember, we just finished talking about quadratics. Quadratics either increase and then start to decrease, or they decrease and then start to increase. They're going to have like this U shape almost. So Kim is definitely quadratic. Use the regression function of a graphing calculator to write a function that could be used to model each total each girl's total number of followers over the first 8 months. All right. So now we're going to type in our data real quick. All right. So here's what we're going to do. Get your calculator out, clear it out, and I want you to go to Stat. And we're going to select the Enter option because I want to edit. Notice I have numbers in my data. I'm going to go up there and I'm going to clear my data out. So I go up to where it says L2 and I press Clear, Enter. I'm going to do the same thing to L1. Clear, Enter. In my L1 column, I'm going to type in the months since the accounts were open. So we're going to go 1, Enter, 2, Enter, 3, Enter, 4, Enter, 5, Enter, 6, Enter, 7, Enter, 8, Enter. What? I made an error, so I got to go back and press 7, Enter, and it'll fix that up for me. In L2's column, I'm going to put Gina's followers. So I'm going to go 37, 42, 46, 52, 56, 63, 66, 72. In L3's column, I'm going to press Cheyenne's data in. 2, 5, 9, 16, 33, 65, 128, 251. And in the last one, I'm going to put in Kim's data. 16, 29, 38, 42, 43, 39, 31, and 20. Please make sure that all of your numbers have all of your columns have the same amount of entries. That means we know we've put in the data, or the right amount of data, I should say. I'm going to go ahead and I'm going to get back to my main screen by pressing the blue key and then Mode, and that'll get me back to the home screen. And it asks us to do the regressions for each of the following. Okay, so we're going to start off with Gina. Gina was a linear function, we said. So we're going to do Stat, and we're going to go over to Calculate. And I want a linear regression, this form of AX plus B. So I go down to option 4, and I press Enter. Now, Gina's data was stored in L1 was everybody's months, but her data was that first column, so it's X2. I meant L2, sorry. So I'm going to leave that as is, and then I go down here to where it says Calculate, and I'm going to press Enter. And it's going to give me a value back for both A and B. And I'm going to write the equation just like it is up here, but where A is, I'm going to put 5, and where B is, I'm going to put that 31.75. So this is going to be y equals 5 plus, 5x plus 31.75. Cheyenne, we said, was an exponential function. Now, Cheyenne was in the L3 column, so please watch what we do here. We're going to go to Stat, go over to Calculate. This time, she's an exponential function, so I got to go find the exponential function. There it is, number 0. But I don't need to pull Gina's data. I need to pull Cheyenne's data. So please watch what I do here. See the little L3 right here? Right above the number 3? And notice how it's a blue L3? So I need to press second 3. And notice it changed to L3 here. Now we're going to go to Calculate. Look at the way that this is set up. Y equals A times B to the X power. Y equals A times B to the x power. All right, so we're going to write that up. We're going to round these. We obviously don't want to write all of those numbers. So I'm going to do 3 places behind the decimal. So we're going to do 1.136 parentheses 1.964, because that next digit was a 9. So we need to round up. And this is raised to the x power. So I got a little exponent of x. Last thing we're going to do is the quadratic with Kim's formula. Kim's data. So we're going to go to Stat, over to Calculate. This is a quadratic. So we're going to go to the option Quad. Press Enter. But remember that Kim's data is no longer stored in L3. It's stored in L4. See that little L4 above the number 4? It's blue in color. So we're going to do second 4 and go down to Calculate. Ooh. Notice this equation. A quadratic is of the form y equals ax squared plus bx plus c. All right, so we're going to write this down. Y equals negative 2.048 x squared plus, sorry, my glare over there. We've got 18.929, because we're rounding, x. So I'm just plugging in for A, B, and C respectively, minus 0.714. I know I did a lot of information in this first set. Please take a moment to answer or get this copied over, and then we have a debriefing on the next slide.